This project deals with something every middle-aged person should be concerned with. I'm talking about how to ride awesome wheelies on a dirt bike. There's a lot of videos out there about how to ride wheelies, different tricks and tips from the pros. A lot of them seem to fall into the category of it's easy if you already know how to do it. So with that in mind, I came up with my own 3-part plan that's going to be great. I did record a couple before videos with me out practicing. Okay, that's gonna need some work. Whew, how'd that look? Did I get pretty high up there? So part 1 of the plan is about balance and getting used to the balance point. Part 2 is gonna be about trying some of the training apparatus that's out there. And then part 3, I'm gonna throw a little technology at it. So the plan here to get started is to strap this down, raise the front end up, and get used to the feeling of being really high up there and almost falling over the back. Then I decommissioned my motorcycle elevator lift so I could reuse the hoist, which I have attached to the front tire. And I should be able to... Okay, that's really high up there. You can see that it's close to the balance point, so it's easy to push. My weight's obviously going to impact that somewhat. Alright, so that's pretty much it. You can see I lean back just a little bit and I'm just coming unweighted. So that seems really high up there and pretty spooky. Now it does occur to me that you probably wouldn't want to ride all the way up that high because then any gas at all and you'll be over that balance point. So I think probably what you'd want to do is come down a few degrees. That way you can give it gas and be just below the balance point. Maybe. Moving on, that was interesting. I don't know what it really taught me. Part 2, I have this wheelie bar deal that I bought online, and it's supposed to help you ride wheelies by automatically pulling on the brake. So we'll get that installed. So this just bolts up to the swing arm here with some hardware they supply. So this is on and tightened up. And then the front hooks to the rear brake lever right here. And then there's this wheel in the back, and the idea is that when the bike comes up, this wheel hits the ground and automatically pulls on the brake for you. Now the trick obviously will be to get the adjustment set correctly so it pulls on the brake the right amounts. Okay, that's all the way up again, and you can see that this is still not quite kicking in yet, so I think I should adjust that and make it so that it's just starting to pull on the brake. Maybe like a little bit sooner. Okay, that looks about like it. Next step is to try it out, I guess. Well, that was bound to happen sooner or later. Well, that's the end of that. Had a hardware failure. Not quite sure exactly what happened or how it broke. Well, I was looking back through some footage and mystery solved. At some point the cable came unhooked and I didn't notice. Though it's interesting, by that point I was kind of starting to get the hang of it, so from a training wheel standpoint, I guess it kind of worked. Still, I can't help but think it would be nice to have some type of automated safety mechanism that maybe electronically sensed your level and was able to apply a brake or modulate the throttle as needed. Okay, so here's the plan. Automatic wheelie control. I procured these industrial grade electronic level sensors that I'm going to control with these Arduino Nanos. I have a rear brake caliper and a linear actuator that I can control with the Arduino. And then the idea will be to mount these level sensors on the dirt bike, measure the level, and then provide feedback control. And I'm thinking I'll run two independent systems. So one will be reading the level and controlling the rear brake modulation, kind of similar to how that last wheelie bar did it, only hopefully better, probably worse. But and then the second system will tap into the ignition, and I'll use that to dial back the engine RPM when we get up to the vertical position. So I have the second caliper. Obviously I can't use the original bracket it came with because it ties into the axle. I'd hope to be able to just take this off and make my own little bracket, but it's pretty well integrated, this bracket into the brake caliper. So I think what I'll have to do is maybe use part of it. So I'll cut it off and then I'll pick up these attachment points. So I have this bracket cut out and tacked together. So this will pick this bracket up here. And then this bracket will come on top, like there. And then this will pick up the axle on the back wheel. And then the other part is this linear actuator, which I'll bolt to this plate here. And these are always tough to grab onto. This is the main mounting interface. So it'll go something like that. Then I have the master cylinder, and I put a piece of angle iron on there so I can weld that to this, something like this. Then I'll put a little rocker, so when this comes out, this pushes in. So I wired up these electronic inclinometers to an Arduino and a HD card so I can do some data logging. And I went out for a test ride on some dirt roads that were fairly smooth as far as dirt roads go. And back looking at the data, and unfortunately, I don't think these are going to work. This is the electronic data from a level dirt road, so it should be reading 0 degrees, and I'm seeing readings of 15 to 20 degrees. Which is all just due to the sensor noise from the vibrations. And then with a bunch of filtering, it gets a little better, but not good enough, which just isn't accurate enough. So unfortunately, gonna have to find a different solution. So plan B, I got these lidar modules, and these are basically a laser rangefinder, so it measures distance using a laser. And I figure I can mount these, say, on the front end, and then when it lifts up, I can measure the distance off the ground. So I wired these up similarly to a Arduino with some data logging, and went out for a test ride on the same area. And looking at the measurements, these look a lot more stable. The distance from the ground is fairly stable, and then when I look at the variation over several test rides, it's around inch plus or minus 1.5 inches, which is pretty good, and most of the measurements are within plus or minus about 1 inch. So I think that's going to work. So now I can button everything up, finish the brake caliper, get it mounted, finish the Arduinos. I think I'm going to 3D print a little box to hold all the electronics just to keep it a little safer. I'll figure out where to mount these lidar modules, and then I'll be ready for test. Time to mount these lidar sensors. I'm going to have 2 of them. One in the front, probably down low somewhere, wherever I can find to put it. And then one in the back, probably up on the fender here. Thinking something like this for the front. I can screw it to this plate, and then has a little protective flap here so rocks don't kick up in it. Something about like this looks pretty good. View misses the fender, and any rocks kicking up should miss it as well. I'm close to having this finished. Here's the rear lidar installed on the fender. Brake caliper. Here's the front lidar camera installed. Up top is the electronics and some switches. So here's how this is supposed to work. I'll pop the cover off. I have 2 systems here. The right one controls the rear brake. Left one controls the engine. And I can turn one on at a time here. It'll boot up, and then it should give me a heartbeat just to know that it's running. And then as more brake is applied, these green LEDs should light up successively. And then when all 4 are lit up, that should be full brake. And then same thing with the engine control. I need to do some tuning still, namely the distances that these things measure. I'm going to jack up the front end to about the height I want, and then I can get the distance readout, and then I can set those. So this is pretty high up. At this point, I'm going to want things to start kicking in I think I'll want the brake at about 30% on, and I'll want the engine cut out at more like 50%. I want the engine to start cutting out first, and then I want the brake as more of like a second safety measure. I'll test this out with the new distances programmed in. So it's running, I can tell by the heartbeat. I start to go up. There's the first one, second, third, and then that's full brake. And then same story on the front lidar, except this one gets further away from the ground as you go up, so I have to reverse the numbers. And then the last thing to check is, are the engine RPMs being dialed back like they're supposed to be? So I have this meter hooked up, and this is basically 0. And then as I raise this up, we should see a square wave. So the duty cycle we're seeing here is how much the engine's being dialed back. So this is basically mostly on and a little bit off. That's like half and half, 50%. And 2 green lights are on. That's like 75% off. And then that's full stop. I think that's about everything except for the final test. By the way, I realize this is probably a terrible idea, but you know what?
Not if it works.
For these first tests, I did adjust the offsets by about 10 inches. I dialed everything back just so it kicks in sooner to make sure everything's working. Okay, so that was kind of working, but the brake was kicking in before the engine control, so I kind of want to swap those. So I'm going to fine-tune the offsets a little bit. Well, that's the project. It's working about as good as I could have hoped for. I could still do a little bit more fine-tuning, maybe some more test rides, and maybe one day I'll try it on the asphalt with the Supermoto wheels. But for now, I'm going to call it a success.